Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so you can help your kids with math. So, John, today we're discussing the associative property of addition. And when I was growing up, I learned this, I want to say in middle school, but my understanding is they're introducing it earlier now in the curriculum, maybe around third grade. Is that right?
That's correct. Students learn the associative property as early as third or fourth grade. And while it sounds like a very scary word, the premise behind it is that students can take a longer problem like adding three things up or multiplying three numbers together and break it up into maybe only adding two at once first and then adding the third. And they have some freedom and flexibility in the order they want to do that in. So for example, if we have the problem 5 plus 12 plus 1, we can choose how we want to divide this task up so that it's easier for the student. And we call them addends, like 5 plus 12 is an addend, or 12 plus 1 is an addend. And we have two different ways we can do that. So if a student finds 5 plus 12 to be something very doable or convenient, the student can add that up together first to get 17, then add the 1 to get 18. Or equivalently, perhaps the student knows that 12 plus 1 is 13. That might be a little bit faster for the student. So the student can perform that sum first and then just add the 5 onto 13, the sum of 12 and 1, to get 18. Looking vertically upwards toward order of operations, PEMDAS, and all of that, the parentheses is a way to prioritize grouping. So it just means that we're doing that particular operation first and then doing whatever is left over after that.
Okay, great. So I'm going to just start another quick problem here to kind of tell you what I heard in your explanation. Let's just say 2 plus 3 plus 4. So the addends are the numbers being added. So 2 is an addend, 3 is an addend, and 4 is an addend. And the associative property, I'm thinking like what you associate with. And so the number 3, you know what this reminds me of? This reminds me of a dinner party. So if you're number 3 at a noisy dinner party, right, you have the choice. You can either turn and talk to number 4, or you can turn and talk to number 2. And you could do either one, whichever one you prefer. And that's totally fine. You can associate with either number on either side of you. So this problem could be done. Maybe 3 wants to turn to their right. It could be done like that. And as John said, the parentheses we handle first. So we get 2 plus 7, and we get 9. Or writing the original problem out again, because addition is associative, 3 could have been grouped with 2 first. You could have associated with 2 first. And again, we handle the parentheses first. So that gives us 5 plus 4, and that gives us 9. So either way, we get the same sum. Great. I like it, John.
Yeah, and like I said, it comes down to usually comfort level. Like a lot of times students are familiar with 5s and 10s and 15s because they learn how to skip count, or they're used to blocks or breaking down 5 and 10 into smaller things. So it might be that the student might recognize 2 plus 3 a bit quicker than, say, a 3 plus 4.
Excellent. All right. So let's take a look at some problems we could see. Okay, so I'm going to tackle this problem on the left. 13 plus 84 plus 6 plus 7. So it's got 4 addends. 4 numbers are being added. And the first thing I notice is if we group the 84 and the 6, which we can do because addition is associative, 84 plus 6 goes to 90, which is very easy to do in your head. So I'm going to handle the parentheses first. And now, again, it's really your choice how you want to group things. I'm going to decide to group the 90 and the 7 together. I could have decided to group the 13 and the 90 together. So it's going to give me 97. And now I'm just adding those up. So 97 plus 13 is going to give me 110. And I did that all in my head. If I had just gone from left to right, adding 13 to 84, and then that answer to 6, and then that answer to 7, I probably would have had to work it out. The numbers would have been a little bit more cumbersome to do in my head.
Awesome. So I'll do the second problem, find the missing number, 2 plus parentheses blank plus 1 equals parentheses 2 plus 8 plus 1. So based on what you're saying, Alice, I am free since I'm dealing with addition all the way through on both sides of my equation. I'm able to regroup where those parentheses fall because addition is associative. And an equal sign just means that the amount on each side is the exact same thing. We're sort of maintaining a balance. Okay, so if I have 2 plus 8 plus 1 on the right, then by the associative property, I should be able to regroup the parentheses like this then. Is that right?
Perfect.
2 plus 8
I
plus.
need to talk to the 1 first instead of the 2.
Oh, awesome. So we're at the dinner party.
We're at the dinner party.
So then based on this information, so now I just need to basically make a match because an equal sign is, tipping a scale or keeping things equal. And if I already have a 2 and a 1 on each side, then the thing that has to be, the same, the missing part here is the 8. I need another 8 to maintain the balance. So I would say the missing number is 8. And the reason why this is important is as students move later on into their algebraic careers, they need to understand that an equal sign means equality, it means balance. So when later students tackle a problem like this, associative property might not be their first guess. They may, at that point think more about, variables or things like that. They don't know what is in that blank spot, but they do know that 2 plus 8 plus 1 does add up to 11. So I guess another way students can think about it is, 2 plus watt equals 11. And the watt would have to be 9. I would have to add 9 to 2 to make 11. So to figure out what this unknown number is, I would need to know what plus 1 equals 9, and that number is equal to 8. So I could see the traces of like algebraic thinking in this seemingly innocent associative property problem. So it's really important students see it early on as they get ready to move into the more abstract.
Yeah, that's a great point. They're basically finding an unknown, just at this point without a variable, but those days will come soon enough.
Great. So this was a little discussion on associative property. Feel free to check out our next video, which will be on commutative property, which quite honestly gets often interchanged incorrectly among teachers and students. So we'll help demystify that for you in our next video.
Thanks so much for watching, and please subscribe to our YouTube channel. We're at Math Videos for Parents. Have a great day.
Thank you.